Hello everyone. In this video I'm going to talk about some electrostatic, and mainly I'm going to talk about the electrostatic force. In other words, is the force between two charged particles. Okay. Now, charges come in two kinds: a positive charge and a negative charge. For instance, a proton is positive and an electron is negative. So let's just look at some examples here. Let's say I have an object here, okay, and it has, let's say, what is that? Eight protons, and let's say it has 1, 2, 3, 4, 5 electrons. So I think the charge on this is positive because it has more protons than electrons. Now, how do we find the charge of this? Well, the symbol for charge is Q. Okay, so the charge of a proton and the charge of an electron are the same. So that's 1.6 times 10 to the negative 19 coulombs, which is the unit for charge. So this is an electron, okay, or a proton. So we do E minus or E plus. So this is plus or minus, depending on whether it's a proton or an electron. So here, the Q is basically how much excess or deficit do you have in electrons or protons. So here it looks like I have an extra 3 protons. So formula goes something like this: Ne. So this N is 3. That's the difference, the excess, not the difference, the excess. So it's 3 times 1.6, 10 to the negative 19. Now you have to decide whether to make this positive or negative. Well, you have more protons than electrons, so your charge will be positive. So you leave that as a plus. Let's look at the other case. Let's say I had, what is that, 5, 6, 7, 8, 9, 10. So I have an extra 2 electrons than protons. So this becomes a 2, okay? And this becomes negative. Okay, good. Now let's look at another example where maybe I take an object, let's call it A, and I'll take an object, let's call it B. And the net charge on here is, let's say, it has an excess of 3 protons, and this one has an excess of maybe 8 electrons. Okay? So what I'm showing you here is just the net charge. Okay. So if I put these guys together, okay, if I allow them to touch, in other words, okay, if I allow them to charge, to touch, I think you can see that the net charge, what is it? 1, 2, 3, 4, 5, 6, 7, 8. So I'll make it an even number. That's 9. Okay? So I think if I put them together, the net charge will be positive 3 minus 9. 2, 3, 4, 5, 6. Yeah, minus 9. So it's going to be a negative 6. Okay? That's the net when I combine them. Now, after I combine them, I decide to separate them. Okay? So if I decide to separate them, that negative 6 has to be divided equally between A and B. So this will have a negative 3, and this will have a negative 3. Okay? Just in case a question like that comes up. Hi, I just want to clarify something. When I say there is a charge of negative 3 here and negative 3 here, I didn't mean charge. I meant like there is an excess of 3 electrons on this object and an excess of 3 electrons on the other side. So if you want to find the charge here, technically, which will be the same in both, it will be 3, which is the number of extra electrons than protons, times the charge of 1 electron. Okay? But since your charge is negative, you just throw a negative in there. If you had more pluses, then you would put a plus in there. Just wanted to clarify that. Okay, now let's talk about the electrostatic force. So the electrostatic force is the force between two charged objects. It should look familiar. Okay? So it's K, Q1, Q2 over R squared, or sometimes I write it as D squared. It doesn't matter, but the D is the distance between the two charges. So let's say I have a charge here that's Q1, I have a charge here that's Q2. If I want to find the force between them, This is R. This K is a given number, 9 times 10 to the 9th. I'm not going to write the units here. That's not important. Now, this force, okay, so let's see what happens to this force if we start to make changes. Okay, so let's say the force between these two charges, the way they are now, is 1F. They're separated by 1R. It's 1Q1, 1Q2, and the force is 1F. Well, what happens if I make this charge twice as much here, okay, and I make this charge maybe 3 times as much, but this time I separate them by a distance of 2R. How does the force here compare to the force I had earlier? Very simple. So what you do, anything that's constant gets a 1. You ignore it, in other words. This Q1 changed by a factor of 2. This Q2 changed by a factor of 3. This R changed by a factor of 2, but there's a square on top of it. Okay, so let's say that's 6 over 4. So this force here is 6/4 what it used to be up here. Okay, good. Now, so just be careful with that inverse square law business. Now let's say I have a charge Q1 here, Q2 here, the same charges I had before, but this time I'm going to cut the distance in half. I'm going to multiply this by 3. I'm going to multiply this by 4. Okay, let's see what happens to the force. Well, when I had them as Q1 here, Q2 here, separated by distance R, I say the force is 1R. Well, let's see what happens here. The K is constant, so we're going to use this. The K is constant, so we don't worry about it. This Q became a 3. Let me do that in a different color. This Q became a 4. This R became a half. But you have to square it. That's what a lot of times people forget. So that's 12 times, when you do this, it becomes a 4th and you have to flip it. So this is 40 times what you had. So in other words, if this force is 100 newtons, this force will be 48 hundredths. If this is 10, this will be 48 times 10. All right, so let's do an example where we have multiple charges, and we're going to make them in line. So for this class, we're just going to keep them in line. And I'm going to call them A, B, and C. And let's say this charge A is 2 times 10 to the negative 6 coulombs, or 2 microcoulombs, the same thing. B has a charge of, let's say, negative 5 microcoulombs, and C has a charge of 3 microcoulombs, okay? And let's put some distances here. So let's say this distance here is 1 meter. This distance here is 2 meters, okay? Yeah, or maybe 1.2 meters, okay? Not to be boring. All right, so I'm gonna try to figure out the forces acting on B for now, let's say, okay? Now, when you're dealing with forces, you do not put the negatives. If any of the charges is negative, ignore it. Do the magnitude. So let's see what happens to B. Well, A is positive, C is positive, B is negative, okay? So let's see what's going to happen to it. Well, B, I think, is going to be attracted towards C. So it's going to be a force this way. So I'm going to say F of C on B. That's what I want to call it. A is going to attract B, so it's going to experience a force this way. Okay? Now, what I'm going to do, I'm going to find the magnitude of FAB without the signs. So it's going to be K, which is 9, 10 to the 9. The charge of A, which is 2 times 10 to the negative 6. B is 5, 10 to the negative 6. See how I didn't put the negative here? Divided by the distance between them is 1 square. And you can do the math here. Now let's do F between that C exerts on B. Again, it's 9, 10 to the 9th. The charge of B is 5 e to the negative 6. The charge of C is 3 e to the negative 6 divided by 1.2 square. So let me get my calculator and do this. Okay. Well, I think the top we can do quickly. So that's 18 times 9 is 90. 90, we're going to divide by 1 square, so 90 e to the negative 3, okay, newtons. Okay, FCB is going to be 9, second E 9 times 15 second E negative 12 divided by 1.2 square. That should give me hold on, did I mess up something here? Let me just try that the long way. Yeah, I think we did it right. Yeah, so this is going to be 0.0938 newtons. This one is going to be, just 0.09 newtons, okay? So I just did the magnitudes. So now, which one is winning? It looks like this one is winning. So the net, or the force acting on B, the net force on B is going to be this guy minus this guy, right? Because this one is winning. So it's going to be 0.0938 minus 0.09, and you can do the math. That's the net force on B. Okay, good. So now let's do something else. Don't want to erase everything. Okay. Well, let's see what happens. Maybe we want to study what happens to A. Okay. So A is being attracted by B. So I think I can call this F B on A. I should have left it because F B on A and F A on B is the same thing. That's all right. F B on A, and then this is going to be F C on A. Okay, this one I didn't have. So C looks like it's going to repel A because they are the same sign. So this is FC on A. Again, we're going to subtract. Okay? I was hoping we can add. Let's do one with the addition, actually. Let's change things a little bit. Okay, let's do that. So I'm going to put them like that. So I'm going to put A here, B here, C here. I'm going to make this 1.2 meters still. This is 1 meter. I'm going to keep this as positive. I'm going to make this negative. And I think I'm going to make this negative. Yeah, that's what I'm going to do. So I'm going to figure out the force acting on A from B and C. So B is going to attract it. Okay, C is also going to attract it. So you're going to have F that B exerts on A. I'm going to have F that C exerts on A. See, in this case, you have to add them because they are going together. If they were both going to the left, you add them and you put a minus in front of that. So F that the B exerts on A is equal to 9 e to the 9th. Now, the charge of A is 2, 10 to the negative 6. The charge of B is 5, 10 to the negative 6 divided by 1 square. Okay? And I think I did this before, did I? Yeah. This is 90 e to the negative 3 newtons. So what is that? That's 90. Yeah, that's fine. So, and then I'm going to do the force that C exerts on A. In magnitude, again, I'm going to drop the signs. So it's 9 e to the 9th, 2 e to the negative 6. C has a charge of 3 e to the negative 6 in magnitude divided by 1.2 square equals. So we can use a calculator for this. So I can see 54. Yeah, 54 second E negative 3 divided by 1.2 square. I get 0.0375, and this one should give us 0.09 newtons. Must put the units in there. Now, which means the F net on A, okay, the combination is equal to the sum of these two because they're going together. Okay? If both forces were going left, we'll do the net, we add them still, and we just throw a negative in there. So it's going to be 0.09 plus 0.0375, and that's going to be your net force. And that's basically the superposition of forces acting on a single charge. Okay, thank you.